Have you ever wished there was a tool that could bring real precision gear generation and control to your Blender projects? Well, here it is with Precision Gears. This add-on is specifically designed to dramatically enhance how creative makers like us create, design, and animate gears in Blender. This video, we're going to explore all of the current features of Precision Gears, from its parametric system with a diverse range of gear types to the powerful rigging capabilities. We're about to change the way you design gears in Blender forever. So let's get started. And just quickly, a small portion of this video is sponsored by Brilliant.org. So first of all, this is how to download it and get it installed. And this is pretty much the same workflow for updating it as well. So I'm going to open up a window here. This here is the Blender Market link. I also have a Gumroad, and on my Gumroad, I have a whole bunch of other cool things. Small little upsell to the precision bolts. You might enjoy that. Also take a look at CAD Sketcher. There's a lot going on here. So we click on Precision Gears, and here we have it. You can see it is $8. I suggest that you put in 15 so I can carry on further development. Thanks for all of you that have already put in 15. That is why I've been able to add so much more to this. But for those of you that are looking for a free version, click down in here. There is a Precision Gears Lite version. Just be aware that it is the Lite version. It just has a Spur Gear, it has no rigging, and none of the really crazy tooth modifications that come with the full version of Precision Gears, but also 90% of gears are Spur Gears. Once you put in whatever amount it is that you want to put in there, click Add to Cart, go through the buying process, and you'll get a nice little zip file that we will get installed here in Blender. So head on over to Edit, then Preferences, go to Add-ons, click Install, and find that zip file. For me, it's right here. For Mac OS users, just be aware, make sure that it is zipped up. It needs to be in a full folder. Sometimes Mac OS likes to open up zips for no reason. So there it is. Get it installed. Once it's installed, make sure you turn it on, do a little refresh, and honestly, I would suggest that the best thing to do here is do a full Blender reset. So that's what exactly I'm going to do. I'm going to close Blender and open it back up. Now, just before we dive deep into Precision Gears, there's one really important setup that you have to do in Blender, which is what I like to call the Precision Ready Blender file. Now, it's under here. You'll see your unit scale underneath the scene properties needs to be set to 0.001, and you also have to make sure that your length is set up to millimeters so everything makes sense. Now, this is super important because Blender is set up for meters and Precision Gears is set up for millimeters. So if you do not do this setting, basically everything's going to be 1,000 times bigger. I have an entire video that explains precision modeling in Blender and how to set up that file. It's linked in the card or down in the description, but now that you know that, let's dive into Precision Gears. So first, let's cover the absolute fundamental basics of Precision Gears. I'm going to select the default cube, delete it away, press Shift-A. Under Mesh, you'll find Precision Gears. Personally, I like to right-click this and add it to my quick favorite, so then all I have to do is press Q. There it is, Precision Gears, and then I'm going to add a Spur Gear. I'm going to left-click to select it, press backtick and go View Selected. You can also press period on your numpad, and there you have it. Now, where do the settings go? Don't worry, we're going to go into a lot more depth in just a moment, but let me show you all the other gears. I already have them made here. We have the lovely Rack Gear, we have the Spur Gear, Internal Gear, Bevel Gear, Worm Gear, and the GT2 gear, or belt gear. Now, all of the settings for all of the gears are all in the same place, which is under the Object Properties panel right here. Click there, scroll down, and you'll have a lovely new drop-down, which is the Precision Gears. Precision Gears right here, this is the hub. This controls everything of each and every gear. It is very extensive, but let's start from the top. First, we have the lovely presets, so I can click in here. It's nice and simple. If you have any other preset ideas that you'd like me to create, let me know down in the comments or over in the Discord. I'll say, hey, I want that gear there. I can apply that preset. You know what? I really want the set screw of this gear, though, on that one. So I'm just going to turn those all off. Actually, no, I want the bore of that one. I want the extrusion and the set screw. I'll click apply, and that adds it to the gear. So it is very, very powerful. From here, you can basically just go back to the presets, just change them up however you want. You can create your own presets. There's a whole bunch of links here. And this one right here, this refreshes the thumbnails. If you're creating presets yourself, you can search through the presets. There's so much to it. Truly, it's very, very overwhelming sometimes. But the absolute basics of gears is right here in the parameters. Now, we're not going to cover this in absolute huge detail because there's so much about gears to cover. So I'm not going to be able to do that, but I can do the absolute fundamentals. So first, gears have teeth, and this is the tooth count. Then the module is the size of those teeth. And then we have something called the pressure angle. Now, if you don't know much about gears, the pressure angle is basically the angle of this right there. Now, usually there's a standard of 14.5. This is sort of the most standard one. The other most standard one is 20. So if I put in 20, you'll see that I've got a whole bunch of gears in 20. And recently there's also a new standard of about 25 as well. In a nutshell, all you've got to think is that the lower the pressure angle is, so the 14.5, the quieter the gear is going to be. However, it can't handle as much torque. The higher the pressure angle, the more torque it can handle, but the noisier that gear is going to be. So lastly, to just sort of do an overview, finish off this overview anyway, is let's deal with the rigging. There's a whole bunch of other extras to really go into here, and we will in just a moment, but I think the last little thing here is the actual rigging aspect of things. So I'm going to move the lovely rack gear and the spur gear down here. I'm going to select this spur gear, and I want this to be the main core driving aspect of the rig. So I'm going to click here and then turn on rigging. Now be aware, what it's just created there is a rigging system. That is not a gear. Forget about that. What's going to be created there is the entire gear chain. All of the gear is going to be right there. So the actual gear is still here. So any changes that you do to this will change the rig. Now let's get our rack gear and say, hey, I want this to be rigged as well. So we turn it on and it's created its own rigging system. Now that's not a problem. That's a feature because you can now have multiple rigging systems. But instead we're going to say that lovely rack gear, I want that to be part of the spur gear. So I'm going to say your driver is this gear here. It will look at whichever rigging system it's part of and then join it and remove its old rigging system, and there we have this. Now it's not exactly joining up very well, is it? So let's click here, go all the way down to where it says the rigging, open up the drop down of the rigging, and you'll find it right here. Attempt intersect solve. Okay, it's not really doing well. Why is that? Well, it's because the actual teeth themselves don't match correctly. So match the driver. And now when we do attempt intersect solve, it solves it pretty much perfectly. So from here, let's animate this. So we're just going to say, hey, use the timeline. We're going to say this to be 1000 frames so that it's nice and slow for the video. And then from here, let's just get a nice good look at what's going on here. We'll hit play, and that is now animated away. Now we're going to go into a lot more depth in just a moment. Now, as we delve deeper into the fascinating world of precision gears, you may find yourself wanting to learn more about the complex mathematics and science behind these mechanical wonders. Well, there's a free and easy way to do just that with today's video sponsor, Brilliant.org. Brilliant is a platform that brings abstract concepts to life with interactive bite-sized lessons, and they have a course specifically designed to foster a deeper understanding in the principles behind gears and a myriad of other phenomena in their scientific thinking course. In this course, you'll encounter lessons that mimic the real world, teaching you to think scientifically through puzzles. For example, one lesson dives into the concept of gear ratios, explaining their significance in how gears work. And it doesn't just stop at gears. You'll explore the principles of leverage, tension, gravity, and more, each presented through fun, interactive problems to solve. Brilliant's approach helps you crack today's problems and prepares you with the skills for tomorrow's challenges, all in just 15 minutes a day. It's like having your own personal learning coach, accessible anywhere at any time. So why not gear up your learning today and try everything that Brilliant has to offer for 30 days for free? If you're among the first 200 people to sign up using brilliant.org/makertales, you'll also enjoy a 20% discount on an annual subscription. And a big thank you to brilliant.org for sponsoring this video. So as you've seen, there is a lot inside of Precision Gears. I'm honestly not going to be able to cover absolutely every single gear individually and all of the settings, because this video would go way too long and there's a lot of deeper understanding of gears to sort of grab a hold of before you even dive into all of that. So what I would really suggest is watch this. We're going to go into more in-depth detail of the Spur Gear specifically, because that one, honestly, it correlates with all of the other gears quite nicely, apart from the GT2 gear. And then from there, I want to also show you a couple of other mechanisms, so gear sets and gear trains all together. For instance, I'll show you how to do a planetary gear set. I'll show you how to do bevel gears that have a different tooth counts. I'm not going to show you the spiral gear, it's pretty much exactly the same, but I'm going to just show you all of these different things individually. But first, let's go and dive into a Spur Gear all on its own. So we've got it here, we'll press Q, I'm going to open up a Spur Gear, I'm going to go into the settings of this, and we're going to really now take it nice and slow. From the very beginning, here is the type. You can just go to any gear and flip the type it is. It's going to try and change all of the settings to fit that type. Just be aware that when you're changing from a Spur Gear over to a worm gear, it's not going to be able to do that. They take completely different parameters. But for instance, this here with Bevel Gear, let's change the tooth count, I don't know, let's say 50. So it's now turned into this big bevel gear. I'm wanting to show you all of the things in the Spur Gear, so I'm just going to go here, go to the drop down of Spur, and it's kept as many of the settings as possible. Now be careful, because if you go over here and go into a worm gear, it's just going to break, because you don't get worm gears with 50 teeth. It's just a little bit all over the place. However, you could set this to 2, and it needs to have a little bit more height, maybe 50. And maybe it also needs a diameter, because 4 is way too small. Let's give this a diameter of 50 as well, and now you'll see that it's starting to build up. Things that haven't been taken in is the actual resolution of things. There's much to go here, but main thing here is the rotational steps. There was nothing in the rotational steps of the Spur Gear to start with, so it was way too low to start there. But we're going to go back to the Spur. I'll load the default gear right here, so we'll carry on playing with that. So now you know the type, we can just flip in between them. Now we've got searching gears. You can search a gear that you've already created. You can create your own preset here. You can also open up the folder that has all the presets if you want to copy and paste, or in the future, I might release just gear sets that you can just download and put that in there. And this opens up the website, and this will go and basically create all the thumbnails of all the gears all over again. As you've already shown here, you click in here, select a gear you want. This one here, if I'm wanting just the set screw and extrusion, I would do this. I would click apply, and there you have it. It's that simple, really. It's quite powerful and easy stuff here, and just make sure you have things selected as you want. Now let's go down into the parameters. You already know tooth count, you already know module. The height for this particular use case is the thickness of the gear itself. The pressure angle you already know. The complexity, if we go into wireframe mode and you take a look here, it is literally just how complex are these teeth going to be. It's as simple as that. Then we've got the shift. So shift is a little bit of a strange one. Shifting gears is more of a manufacturing term where you can just decide where the gear is going to be sort of created within its mathematical correctness. So we'll set this all the way to 0. And that is your bog standard gear right there. Now if you increase the shiftness, you'll see it pushes it out. And you can also go in the other way and go in. So depending on many different factors is depending where you want that shift to be. For instance, planetary gears, they're pretty much 0 shift. You don't want to go anywhere crazy with that, but some other gears you want a shift of 0.5, and the default is 0.5 inside of precision gears. Now the head has to do with this here. how much is the head going to push. Now, it can break, so be aware, you can absolutely break this. So just be aware that if you want it to be much smaller, much shorter, you can do it right there. For instance, if we had a shift down here, you can also bring down that head to make this a really strange gear. So with that back, let's just put those all back to where I set them up by default. Then we've got the backlash. So the backlash is an interesting one. If you find that things are changing too quickly, you can always hold down shift, which makes much, much smaller changes. So the shift is basically, think of the module, which is the thickness. The shift just pushes that in a little bit. It's pretty good for an offset, but if you're wanting actual, for instance, 3D printing offsets, we have an entire thing just for that later on down in here. So I'm going to go and set that to there. Now, helix angle. Here's where we start to get into some interesting things about gears. We have helix angles. So you can turn this into a spiral-esque gear or a helical gear. So we can set the helix angle here, and you'll see that, oh no, it's gone way too much there. Let's actually just set it to 45, a little bit more. Let's go 75. Okay, that is really quite intense there. Let's create the module a little bit bigger, and let's look at the wireframe. You'll see that there's not many steps in this. Hold on, let me see if I can get this to be a little bit more visual. See, there's not many steps going on in here, and that's what this Z resolution is. You can increase the resolution of the Z steps or decrease it. You can go absolutely crazy here. But for now, I'm going to change this to 45 for a reason in just 2 moments, but you can have this be very much no steps whatsoever or add steps, so it's more of a curve. And then the next one, let me just get us over into this view once again, is the clearance. So clearance is the inside part. So where the tooth comes in, the clearance is where the tooth tip is to the gear. That is the clearance part there. So you've got the clearance and you've got the backlash. There's a lot there. Be aware that the backlash also means that gears can rattle a bit. Okay, now we've got 2 more, which is the herringbone. Now, because we have a helical angle already in place here, you can click herringbone, boom, and it will take the helical angle and use that for the herringbone, because you can actually create different types of angular herringbone using this. You can also go in the other direction. It is really quite cool stuff. Now, I want to turn off the herringbone here, and there's something called the undercut. Now, undercut might not be that obvious with this gear, but right here, it will round out that edge. Now, you see this a lot more with smaller gears with smaller tooth counts, as well as a shift that is much lower. You see already with the shift of 0, it's made that round edge. If we also make these a lot smaller, now you have this rounding going on there. Let me also go, I think it is on the shift that I go minus. You can go inwards. This here is the undercut. It means that the tooth itself of the gear is going to go under, around into that curve. So just be aware, that's how you get the whole idea of undercut gears. Now I'm just going to load up the default here. If not, we're going to get into a whole world of mess here. Okay, that is the basics. Now coming into a whole other thing, tooth modifications. Now this is where we go into the realm of gears that have never been created before, and you can go into creating sci-fi, whatnot, play around, see if these actually have other properties within gears that might be useful for your use cases. But let's go in here. Tooth modifications. You turn it on. Once you turn it on, you have a whole bunch of other settings. So let's just go into these one by one. You can taper tooth inwards. You can also taper the offset this way. You've also got the taper resolution, which if we just go tip relief, we go this one here, and you've got the resolution of that tip relief. It's all pretty self-explanatory. Now the worm gear cut, you'll see this lovely thing here. Worm gear cuts are so tricky to understand. They truly are, which is why they are automated, and I'm going to show you that later on. But this is how you do worm tier cuts. And then here, tapering has a limited compatibility with the flank modifying of all this here. So let's just go back to the default gear to show you those last two there. So go back to the default, turn on tooth modification. Now we've got flanking, so I'm going to turn on crowning. So crowning does this lovely little rounding of gears. And we've also got end relief. We've got the amount and the distance. It is very, remember, we're dealing with absolute teeny tiny precision. And you can bring all of these together to create some really crazy gears. I don't think there's ever been something like this. I don't really know why you would make something like this. But let's see, let's go for a taper as well, going this way. And why not? Let's give it a worm cut as well. Look at that. That is an insane gear. I've never seen anything like that. Okay, so now we've done this lovely bit here. Let's go into the next one, which is the bore. Now, if you don't know what a bore is, it basically means the hole in the middle. Now, there's many different types of bores, and if you click on here, you'll see you can click and go through all of them. So let's just go through them. The first one is no bore at all. If you don't want to have a hole in this gear, you don't need to have one. You can then go into the cross, and here's where things start to get a little bit weird. You have to basically start pulling these out on the Y and the X to get this cross out. This is why I've tried my best to give you presets that have everything. So you can click on the cross one here, turn off all of this right here, and just apply the cross. And there you have it. Nice, quick, and easy. Now, with that, there is also the round subtract. The round subtract basically will go in here. We can put in whatever resolution that we're wanting, whatever radius that we're wanting. And you can also click a preview that lets you know what exactly is going to be cut away here. So let's go and move this cutter position as well as the cutter size. So let me just play around with this a little bit so we get exactly what we understand that's going to happen here. Radius, cutter position. Oh, the cutter position is too far. Let's set that to 0. And now we can push this cutter position out. This is Boolean driven, so just be aware of it. So right this minute we have this mirroring. We could say don't mirror. I just want it to be on one side, so you get a D. If you want, I think it's called a double D, you go like this, and then you get this lovely amount here. There's a lot in here. I know it's a lot, but for instance, this is a pretty good one that if we go and turn off the mirror, you can go here and do an extrusion, which I'm just going to mention now because it works very well with the bore types. So I'll turn on the extrusion. We'll do an extrusion of 5 millimeters and make sure that it's a radius bigger than our hole. So we'll go for 50. Oh, 150 is way too big. 15. And now we have this extrusion right there. Maybe that's still a little bit much. Let's maybe go for a radius of 10. That works well. Let's go extrude this up by 10 as well. And here we can go and add a set screw. You can also flip this to be on the other side as well, or on both sides. And let's quickly set that set screw. Don't worry, we'll come back to the bore. We'll turn on the set screw. And you'll first be like, where on earth is it? It is because it's teeny tiny right now. We've got to set a radius. Let's go for 2.5. And if you don't see it, you can click preview here. And if you're not seeing it, that's because it's probably turned off with its arrangement set to 0. You've got to turn it on with 1 because there are many different types of set screws. So the set screw is currently in the gear itself. You do get set screws that are set inside of the gear. So from here, we can do an offset, push this upwards over to here. And this is not a very good set screw. We want it over here. So you can go for the offset. No, not the offset. I always forget which one it is. The angle, and we can set this to 90. And then we'll be right there where that D cutout is. Now, the other arrangements is you've got 1 set screw, 2 set screws, 3 set screws, well, opposite, and then you also do have 3, and you've got 4. So, a whole bunch of different set screws. Those are them in a nutshell. I'm going to just turn off the set screw now. We will turn off the extrusion now, finish off with these bores. There is the round subtract, which is the one that we have right now, then we have the round add, also known as the keyhole. So we're going to go for a union scale, set this to 10, and then we'll just move the position of this union position. We'll go all the way, let's go something more around here, and set this union scale down to 5. And now you have a nice little keyhole. Remember, all of these are in the presets as well. And then we have the polygon one. Also, this one just lets you do a whole bunch. This lets you do just a nice square one. You can do triangle ones, hexagons, round ones, you name it. Whatever type of bore, you can do it right there. Okay, I think that was enough getting into all the nitty-gritty details of all of the settings. We are going to now start to touch on the rigging. There's also some other general settings here. This is the type of Boolean operations. You can say do it all fast, but you can have weird things going there. Make it exact. Usually it's going to work just fine. The weld operation here, this is what is automatically applied in your modifiers. Just be aware that if you're working in the meters, this 0.1 weld is going to be a little bit too big, so you might have to set that to be much, much smaller. This is also a scale factor, so if you are working in meters, you can do a scale factor here and set this to 0.001, and then that will scale it 1,000 times smaller. You've also got unwrapping, seam alignment, and creases for those that are doing texturing of these lovely gears. Then there is attributes for those that are wanting to deal with gears and working with all the lovely maths that is in there. Again, go and check out this video sponsor. Truly, I took them as a sponsor because there is some amazing knowledge in there. Is the addendum, the dedendum, tooth depth, working depth, pitch, and all of that. If you're trying to get those created, it's there. There's so much to do with gears, and we're going to talk about all of that stuff to do with gears right after this. So let's go and get on with rigging some really quite interesting concepts over here. Let's just press play, take a look at all of this good stuff going on here. And to do all that, we'll dive in right now. So when it comes to these gear sets, it starts to get a bit technical. So let's take it right back. I have covered the generation of gears pretty widely, but not the actual sort of how they're made. And that is sort of a little bit needed just to make sure that you have an understanding of everything that's about to go on. So here we go. I'm going to bring in a Spur Gear. So the Spur Gear is right here. We're going to change this up so that you understand what's going on, because many people think that you go with a gear, it's like, oh, I want a gear that is 10 centimeters in diameter. That is not how gear generation works. The way that gear generation works is you go by the tooth count times the module is the circumference of the pitch circle. What the hell did I just say there? So let's make this super simple, super easy numbers. I'm going to set this to 10 teeth with a module of 5. We're going to set the pressure angle to 20. I'm going to set the shift to 0 because I want to work with the absolute core gear here. We're going to go with a clearance of 0 as well. So this is the fundamental gear shape. Now from here we can go down to the attributes, and there's all these definitions, the addendum, the dedendum, and all of that. What I'm wanting to tell you is the pitch radius here and the pitch diameter. That's what we've created, because 10 times 5 is 50. 50 divided by 2 gives me the radius of the pitch radius. Now I'm telling you this because if we now create ourselves a curve, actually let's just go for a circle here, and I'm going to make this circle be a radius of 25. I'm going to set the vertices to 100. I'm going to press G, move this up here on the Z. I'm going to press Shift D to duplicate it on the Y and move that by 50. I can now tell you that if I were to rig this gear up, that intersection point right there is where the gears are going to actually touch. So let me actually show you that. So I'll press G, X, move it over there. We'll go all the way down here, and just before I rig it, I'm going to just do a Shift D to duplicate it and move it out here to the side. We're going to turn on rigging on this one, go over here, turn on rigging, and then we're going to say, hey, I want you to be rigged with this one over here. Make sure that we do an intersect solve. We're going to take a look from the top up. Let's go use the timeline. Let's say 250 frames. And now when we get nice and close here, this here is when I press play. You're going to see right there, that is exactly where this gear is interacting with one another. So that's what I want you to sort of understand. Gears are complicated beasts. So if you're wanting to make a gear a certain size, you've got to basically find out what the circumference is and then divide that circumference by whatever teeth it is. There's a whole bunch of different calculators online to help you figure this out. Let me know if you want me to do a big deep dive into gears to really help you understand them in this deep manner. But I wanted to first preference that before we go on and create all these cool gear sets. Jumping into the most satisfying gear set, the Planetary Gear Set. So it's got a sun gear, planet gears, and a ring gear. They are at a weird ratio in the sense that there is the sun gear tooth count times 2 of the planet gears equals the tooth count of the ring gear. Don't worry, there's an entire online calculator to do this. It's linked down into the description, and you can change this by figuring out speeds or by the tooth count. It is brilliant. It's linked down there below. So how do you rig it up? It's pretty simple. You have your root driver gear right here. This one has nothing driving it, is just the rigged itself. Then we have these 3 planet gears. They are all onto the sun gear itself, and then you've got the ring gear, which is driven by 1 of the planet gears. Now, something very important. Take a look at what I have set up here. The shift is at 0. The head is at 0. The backlash is at 0. All of these are as fundamental in shape as possible. This will not work if you go out of that. The one that can have a little bit of tweaking is the ring gear itself. You can change the head, and sometimes you want to change the shift just a little bit, but just letting you know, that is what you change. So let's change this up in some way. So I'm going to go over to the sun gear here. Let's put this up, I don't know, let's go to 30. So now that that is at 30, things are not adding up, but it's fine. I don't want to change the planet gears, but the planet gears, let's see, they are 18, and this is now 30. So the new number for the ring gear would be, what, 66. So I'm going to go 66. Now I'll put it in, make sure that we do an intersect solve across all of them, and click, and there we have it. That is now that planet gear updated. Planet gears are incredibly useful things, incredibly complicated. If things don't work out, just carry on tweaking and playing around with it. It is possible because I've just shown you it twice. Moving on to the lovely complicated world of bevel gears. Well, they're sort of complicated. They're not really complicated. They're pretty simple once you understand it. So first and foremost, we have the simple, lovely 90-degree pinion gear that the tooth count is exactly the same between the two of them, and the key thing here is they have to both be at the pitch angle of 45 degrees. But what happens if you want to set up a different ratio between the two gears? What if you wanted this one to be 20 and the other one to be 10? That's where things start to get a little bit complicated, but just before we go and do that, just one other thing I want to show you of these lovely bevel gears, that you can always split up a different number that is 90 degrees. Instead of going for 45, let's say we actually wanted this union of the two gears to meet up at a 45-degree angle. So that would be the 45 divided by 2, which would give us a lovely pitch angle of 22.5. So 22.5, and I'll go into this one as well and set the pitch angle to be 22.5, and now we have those two bevel gears interacting at a 45-degree angle, which I think is awesome. But let's talk about different ratios, because that's a very important thing when it comes to these lovely bevel gears. And here's where things get a little bit interesting. Technically speaking, the way you can look at it is that this is now a rack, and this is now a pinion gear. And the actual intersection point of these two is calculated by a completely different pitch angle equation, which is this here. But don't worry, you don't actually have to do it, because there's a lovely online calculator for it. So in this example that I have set up here, the tooth count of the pinion is 10. The gear is set up to 30. This here doesn't matter whatsoever. Click compute, and the two numbers that we actually care about are the pitch angle here. 18, you can go down to 3, 4, 5 decimal places if you want, and then you've got the same here of 71. So I'll go here. You'll see that I've already got this one set up to 71.565, and if we go to the pinion itself, we have this set up to 18.434. Okay, that is how this is set up, and then all you do is basically set it up as a normal rigging. You just say, hey, rigging, make sure that this is a bevel connection, and that is that sorted. But what about these crazy screw gears? Well, it's basically the same with a little extra twist. So this is the extra twist. What we have here is the same example, which is a 10 to 30. So the change there is a 1 to 3. Now the angle, the helic angle of this is 1 degree. The helic angle of this one is 3. That is because it is multiplied by the gear ratio that's going on. So if I was to change this to 40, for instance, well, first we're going to have to go back to the calculator here and change this to be 40. And then we're going to get two different angles here. So I'll copy this angle here and we'll whack that into the pitch angle over there. And then we'll also go back into here and we will grab this part right there. And we will whack that into there. However, now you'll see that they're not matching. That is because now the ratio of this is completely different. Let me just stop this spinning because it's quite distracting. This is now no longer matching because this is now a 1 to 4, which means we have to go into our gear here. And remember that our rack is at a 1 degree. So this now has to be minus 4 degrees. So minus 4, and now if we just make sure that this is an intersect solved correctly, this is now going to be matching up perfectly there. We can hit play and you'll see how that matches up. Things do get quite complicated when you get into screw gears. Just be aware of it. They're powerful, they look cool, they are crazy beasts, and it can take a little bit of a while to get a hold of it, to really truly understand it. You might have to do a couple bits of online researching to truly get your head around it, but those lovely calculators are the ones that I've used to really help me out. Right, it's time for a lightning round as this video is getting far too long. Let's dive straight into it. First, we have the GT2 gears. Now, I haven't mentioned much about them, but they're pretty much the same in the sense that all you have to do when it comes to the settings of these, it's just the tooth count that counts here. And there's a whole bunch of online calculators here. They rig up exactly the same. You just do a normal rotational rig to them both, and just be aware that if you're wanting to figure out the center between things, you can go to any rigged component and click cursor to rigged, and it will move the 3D cursor to the rigged component. Then we have herringbone gears. When you try to do basically the intersection match of them both, it's going to look like they don't actually match up. Remember, you can always click on one of these and click match driver. This is going to flip the herringbone gear so that it will actually match up, and then that will match up perfectly. Now, worm gears, they are complicated. So to try and make things as simple as possible, you cannot just get a normal spur to work. With a worm gear, you need a worm wheel. And to create a worm wheel, the simplest thing is rig it up over into a worm gear and then go match driver. This will change up all of the settings to basically work perfectly with it, and then from there you're going to be perfect. Then we have compound gears. Now, compound gears is a way of rigging up gears so that you can have a gear on top of a gear like this. Now, it's very, very simple. All you do is in the rigging, just go from the mode into compound mode. And this means that you're then going to have to do an offset upwards. For instance, this gear is 15 millimeters. It has an offset of 14.9 millimeters. Just be aware that this here is not one gear. It is not booleaned together. It's just sort of to show you the rig itself, because this here is separate on its own entity so that you can do whatever it is that you're wanting to do with it, and then you just carry on rigging as normal. This is a perfect way of basically changing up whatever it is, be it the ratio of the gears, the teeth themselves, whatever. You can go here and create whatever it is you want. Now, while you're working with compound gears like this, you're going to also want to keep a little distance between these gears right here. So there are a whole bunch of other settings in the rigging, including the distance offset, tangent offset, parallel offset. And all of these offsets, they also apply over in the worm gears and all of the other ones. But I wanted to show you it here because this here, the lovely distance one, is how far it is. This is the one that I usually use for 3D printing. I don't like to change things up too much. I just work it with this one. Or you can always change it up with the backlash if you really want. So that's that. Oop, I set the angle wrong there. Let me set that back to -90 over here. Go to the distance, set that to 0. I wanted to show you the tangent offset as well as the parallel offset. So there are a lot of settings here that you can truly get lost with. And now let's talk about something that's a little bit of a elephant in the room, which is, well, hey, these gears are pretty boring, aren't they? Well, then tell me how I'm able to do this. This is one of the incredible things of precision gears, which is we are working through instance rigging, which means that these gears here represent the rig itself. So you can go crazy doing Boolean operations, cutaways, adding things instead of, so for instance, this here, instead of making this a cutaway operation to add all of those cylinder holes in there, I could actually change this into a union. And now I've got a completely different thing going on over there. Just be aware this is super powerful stuff. If you're wanting to know how to do radial arrays like this, then I have an entire video that goes into craziness about that. But that there is sort of the speed run of a whole bunch of other things that can be done with precision gears. And honestly, this is still just scratching the surface. But I think it's a deep enough deep dive into precision gears to get you to feel really what is possible with it. You can truly go crazy with this system. Now, honestly, I'm just getting started with precision gears here. It's taken about 2 years of development to get to this point, thanks to your lovely support and the lovely support of my lovely patrons here. Truly, without you guys, I would not be able to do Maker Tales and a whole bunch of the stuff here. It really makes this all possible. So if you're enjoying what I'm making here and think I'm worthy of your support, I would love to see you there too. Now, if you want to see someone who has been using precision gears for quite some time, that is Shooter. I gave him a copy of precision gears way back when I was still getting a start of the development. I've been using it for a whole bunch of clockwork mechanisms. Truly, it is some amazing stuff there, and I'm planning to go and create some amazing stuff myself. So let me know what it is you would like to see me do with precision gears, as well as any other things that you think precision gears might be missing. And who knows, maybe in future developments I'll be able to add it in. Any further support of precision gears is always loved. You can always just repurchase it if you want, or join my Patreon. It really does mean a lot. Remember that we do have a Discord for precision gears, and that is linked down in the description. Thank you so much for watching. Keep making, and let the quest continue.